Welcome to our Let's Learn channel. Today we are going to see about lenses. Actually, lenses plays a very important role in our daily life. They are used in spectacles, cameras, microscopes, telescopes, film projectors, and many things. So, the working of a lens is based on of course, refraction of light through it. So, a lens is nothing but a transparent bounded, which means glass bounded by two spherical surfaces. So, lenses are of two types. We know very well, convex and concave. Here for convex, it is nothing but if the two surfaces of a lens are convex, it is said to be convex lens. For concave, if the two surfaces of your lens are concave, it is said to be concave lenses. But in convex lenses, it is thick at the middle and thin at the edges. But for concave, it is thin at the middle and thick at the edges. This is what the best example and difference for this. And here I have shown one best example. So here we can say one object bulb. So we are taking convex lens here. So here, the bulb will be magnified and appear bigger than it is real in convex lens. But in concave lens, here it will appear smaller than it really is. So this is a major difference for this. We should remember always. So these are all the best examples for convex lens. Here it is nothing but magnifying lens, eyes and cameras and microscopes, and these are all the basic examples for this. Always we should remember this. Next, these are all the best examples for concave lens. So binoculars, spectacles, and this is we know very well it is a dose spire and flashlights. These are all the best examples. Always we should remember. Next, principal focus and focal length of a convex and concave lens. Here figure A is showing about convex and figure B it is concave lens. So in diagram 1 it is nothing but refraction of light through converging lens, and second diagram showing refraction of light through a diverging lens. Here itself we can easily explain this. So here rays passing from through the convex lens and get refracted according to the laws of refraction. So all the rays close to and parallel to the principal axis. So after passing through the lenses, pass through a common point which is nothing but the focal point. Here it is shown here, right? So it is nothing but denoted by F. So a convex lens is also known as converging lens because how means it converges a parallel beam of light rays. So here all the light rays actually passes through the focus of the convex lens. So a convex lens has a real focus. So this is a basic things we should remember always. So what is a convex lens means we can easily say that is converging lens. Through this we can easily draw a diagram too. So here focal length is nothing but denoted by F. So next one we are going to see about concave lens. Similarly, it is opposite to the convex lens. It is a diverging lens. Here we can say a concave lens diverges a parallel beam of light. So a concave lens is nothing but diverging lens. Here we can say all the rays close to and parallel to the principal axis actually will diverge after passing through the concave lenses. Here, the diverging rays when produced backwards. Here it is shown in a dot lines, right? So this is nothing but appear to meet at a common point, which is nothing but the focal point. So this is nothing also but a principal axis we can tell, or principal focus. So the principal focus of a convex lens is a point on its the principal axis from which light rays originally parallel to the axis appear to diverge after passing through the concave lenses. Here actually we can say the light rays do not actually pass through the focus of a concave lens. A concave lens has a virtual focus which is shown in a dotted right in a green color. So it is virtual focus, which means it is imaginary, means we can think. So these are all the very basic things. Always we should remember this. Next, rules for obtaining images formed by convex and concave lenses. Here the first diagram in figure A showing about convex, and in a figure A second diagram denoting about concave. Similarly everywhere. So in a figure A we can say a path of ray parallel to the principal axis after refraction. So we can say rule number 1 is nothing but an incident ray of light parallel to the principal axis passes through the lens, which means passes through the principal focus of the lens after refraction. So this is a first rule, and second rule we can say that is nothing but an incident ray of light when passing through the optic center of a convex lens goes straight after refracting through the lens. And for here next rule, this is nothing but rule number 3, figure C, showing about path of a ray passing through principal focus. Here an instant ray of light passing through the focus of a convex lens becomes parallel to the principal axis after refracting through the lens. Similarly we can say for concave lenses too. First diagram, here we can say a ray of light parallel to the principal axis of the concave lens appears to be coming from focus after refracting through the lens. So similarly for rule number 2 for concave lenses also we can say it is nothing but an incident ray of light passing through the optic center of concave lenses goes straight after refraction through the lens. So similarly we can say for concave too, this is nothing but a ray of light going towards the focus on another side of the convex, which means concave lens becomes parallel to the what? Principal axis, correct, after refracting through the lens. So these are all the major things we should remember. If we remember these rules means easily we can form the images for convex and concave lenses. So these are the basic rules. Thank you for your attention. Kindly subscribe and like and share.